If alpha is 1-to-1 and onto, then there is a function denoted by that symbol. Is that alpha to the -1 power? It's best to call it alpha inverse. These are functions. Alpha inverse from B to A, such that when you compose it with alpha, you get, how can this be described? You get a function that maps elements to themselves. It's called the identity function, right? Alpha inverse, compose alpha of A is A for all A. Alpha of alpha inverse of B is B for all B. Let's think about a picture. There's A, there's B, here's alpha. We're trying to prove the existence of an alpha inverse going back the other way. I'll use a question mark. Does there exist an alpha inverse? Not in general. If alpha is not 1-to-1 or not onto, then alpha inverse does not exist. Though I will say if alpha is 1-to-1 but not onto, you can make the target set smaller to still define an inverse. If it's 1-to-1 but not onto. Don't worry about that. Alpha is 1-to-1 and onto. How do you show that that alpha inverse in the theorem exists? If you're going to show it exists, the only thing you could possibly do is construct it. What, with a hammer? No. Mathematically construct it, define it. And what you end up doing in this kind of situation is defining it in the only way that makes sense, hopefully. Give me an arbitrary element, little b of capital B. What should I map it to under this function I'm trying to define alpha inverse? It's got to be related to alpha. You got to use alpha somehow. How could you possibly use alpha? Well, alpha is 1-to-1 and onto. Let's take some problem solving. Since it's onto, there's got to be something over here called little a that gets mapped to B, since alpha is onto. And in fact, since alpha is 1-to-1, there's only one element of capital A that gets mapped to B. It's unique. That's the key. That must be what B should get mapped to under alpha inverse. We'll just say it like this. I'll go ahead and use the fact that alpha and beta, alpha is 1-to-1 and onto right away, both of those facts. Since alpha is 1-to-1 and onto, given any little b and capital B, I probably should have said let little b and capital B be given right at the start, but I'm phrasing it this way. It's not wrong. It's just, I think it's better style to say let little b be an element of capital B at the beginning. Given any little b and capital B, there exists a unique backward Z exclamation point means there exists unique. It's not factorial. There exists unique A in capital A such that alpha of A equals B. Define alpha inverse of B to equal A. And we're doing this for any little b in capital B. We can do this. We get a different A in each case, but there will be a unique A for each, a unique little a for each little b. then certainly alpha inverse is a function from B to A. A notation that's often used in that kind of context is this. Write the function name and put a colon and put its domain, in this case B, and its codomain A. I like calling that a codomain, and our author, Joe Gallion, used to call it a codomain, but in this edition, he doesn't. He calls it the range. Oh, I think that's terrible to use the word range. Because range in math, and you'll encounter this as a teacher, those of you who are going to be teachers. Range in math has different meanings to different people. Sometimes they mean it's the entire set that you were mapping to. Sometimes they mean it's all the possible outputs. That's usually what we mean in calculus, is all possible outputs. That's not what our author means by the word range. So I prefer calling it a codomain. I think that's a better, less confusing name. And our author used to do that, but he switched. So it's a function from B to A. The question is, does it satisfy those properties? These two equations. Let's verify that next. Let's start by verifying this one. Give me any little a and capital A. Can I show this is true? Let little a be an element of capital A. We must show alpha inverse compose alpha of little a equals little a. i.e., alpha inverse of alpha of A equals little a. It's basically trivial, but it's a difficult kind of trivial. Is that an oxymoron? It's trivial, but it's a difficult kind of trivial. How do you, it's pretty obviously true, but how do you actually explain it? Think about the picture to help you. A is over here in capital A. Alpha of A is over here in capital B. Maybe I want to make a new picture here. What is alpha inverse of that element of capital B? It's got to be the unique element of capital A that gets mapped to it. Well, that's obviously A. How can I write that in words? Since A is the unique element of capital A that maps to or gets mapped to alpha of A in B, this means alpha inverse of that element of capital B is that unique element A. Done. The picture helps more. Start with an element of capital A, call it little a. It certainly gets mapped to some element of capital B, alpha of A. What is the unique element of capital A that gets mapped to that element? It's A. By definition, alpha inverse of that thing must therefore be A. It's almost too trivial. That's confusing. That happens sometimes. We also need to show the other direction. Let B be an element of capital B. We must show alpha inverse of B equals B, i.e., alpha of alpha inverse of B equals B. Redraw a picture here. Arbitrary element of B. We know by definition, alpha inverse of B, by definition, is the unique element of capital A that gets mapped to B under alpha. That's what we want to show right there. Done. Again, it's almost too trivial. It's confusing. We know alpha inverse of B is the unique element of A that maps to B in B under alpha. Therefore, alpha of that element is, in fact, B, and we're done. It's almost too trivial that it's confusing. It is worthwhile, I'll answer your question in a second. It is worthwhile for you to rethink about this every so often. This kind of argument is going to come up at other times in the course. In particular, I can think of chapter 6, for example, it's going to come up. Maybe in chapter 5 as well. When I say it's trivial, I mean, once you understand it, it's trivial. When you don't understand it, it's not trivial. It is tricky, it's difficult. It's hard to understand because it's abstract. It's hard to understand what to do.